So earlier this semester, you learned about shifting equilibrium. And what you learned was that if you were to increase something here, what it will do is it'll shift the equilibrium that way. But in contrast, if you were to decrease it, it shifts the equilibrium this way. So increasing something makes it go away, and decreasing basically shifts the equilibrium towards what you've decreased. So those two principles are what shifting equilibrium using common ions or acid or base are built on. It's not a hard concept either. So if you add a common ion, it just means that you're adding something that has this in it or something that has this in it. It doesn't have to have both of them. So for example, I could add AgCl and then they both have Ag in it. I wouldn't add the AgCl though because that is not soluble. I would add something really soluble like AgCH3CO2. That would be a better one because all these acetates are super soluble. So I'd add something that's a really soluble ion to the salt. If I can increase the Ag concentration, then what it does is it shifts it this way. Notice that this is the solid side. So adding a common ion will increase the precipitation, or just making more solid, of the solid that is very insoluble anyways. And this can be really helpful if you're trying to get contaminants again out of wastewater, or it comes into play with acid rain. There's a whole lot, not acid rain, but it comes into play with a whole lot of other areas also. So that's one way we can do it. Now the acid rain is the other example. So, well, it depends on what you're adding with acid rain. So if you're adding a common ion, it will shift it this way. But if you're adding something that would form a weak acid with one of these, what you actually are doing is you're decreasing this concentration. And so what I mean is, like, if I add some kind of an H+, it can be like from whatever acid, and that H+ reacts with the S and it makes HS, what that's done is it's moved this out of being in this equilibrium. I now have less S because it's not S2- anymore, it's now HS-. So if I add something that can make a weak acid or a weak base, what I'm really doing is I'm decreasing an ion on this side, and it will cause things to be more soluble and to go into solution more. And again, this also has useful reasons behind it too. So there's a lot of different reasons that you might want to do this, and they're very practical. But just know that adding an acid or a base that makes something weak is really, really helpful. And in terms of making things more soluble.